All right, I want to show you my approach to determining tank hole depth on a job site. Now, I'm going to start from the highest trench in the drain field, but it does require you to have your drain field laid out on contour so that we can make this determination. So we're going to start from the highest trench. Specifically, I'm going to start from the downhill edge of the highest trench and find a shot on ground surface right there. So I'm going to dial this in. And in this case, I am 5 feet, 4.5 inches ground surface right here. Next step, I'm going to look at the permit. The permit is going to give me the maximum trench depth or my trench depth range. Let's just say in this case, we had a trench depth of 24 inches deep. At 24 inches deep, I'm going to move my receiver to reflect trench bottom on this highest trench. So to go deeper, I'm going to move my receiver up and we're going to go 2 feet taller. So I'm at 5, 4.5. I'm going to 7, 4.5 on here. Now, this shot represents the bottom of the trench if I were to dig to make this happy right now, but it's not my goal just to get water to the bottom of the trench. My goal is to actually fill up the entire trench network without backing any water up into supply lines, distribution, or tankage. To achieve that, I'm going to give myself a full 12 inches of product usage here. So I went down 2 feet deep to get to trench bottom. I'm going to assume this is a gravel system today with a 12-inch stone depth. So we're going to come up 12 inches in elevation, which means receiver's going to go down. So we're going to 6, 4.5, which is 12 inches higher than where we are right now. This shot represents the top of the rock, top of the easy flow, top of your product. All right. We're now going to work backwards. Even though I'm going to plumb into the rock lower, I'm going to have enough fall so I could work from this elevation. We're working from here back to my distribution box, which I'm showing an inlet and outlet of my D box with 2 different color flags here. So I've got this elevation. I now need to understand the fall required between the distribution box and the head of this 3-foot wide ditch. So I'm going to take a measurement right here, and it's going to be 4 feet. In this case, from the distribution box to the beginning of this trench, we're required 1/8 of an inch per foot, so that's going to be a minimum of a 1/2 inch fall. Fall coming this way, but I'm going to be working my way back towards the tank, so I'm going to be going uphill, which means I'm going to move the receiver down a minimum of 1/2 inch. We're going to lock that in, and now this elevation is going to be the deepest the outlet of the D box could sit and still get gravity fall to a 2-foot deep ditch, 24-inch trench bottom right here. All right, so now I've got to move from the outlet of my distribution box to the inlet of my distribution box. I need to know something about the box itself. I need to understand that manufacturer, how much difference has he put between the inlet and outlet. In most cases in our state, we're going to have 1 inch of play between the inlet and outlet, but there is some variability in that. Check with your manufacturer. I'm going uphill to the inlet 1 inch, so I'm going to move my receiver down 1 inch, and we'll now be at 6 feet 3 inches in elevation. That now is the elevation, the deepest the inlet invert can be to get gravity fall. Now I've got to get back to my septic tank, and I've got to understand the distance from this point to the outlet edge of my septic tank and understand that there's 1/8 of an inch per foot of fall through that area. So I've measured this already. It's 24 feet. In 24 feet, I need 1/8 of an inch per foot. There's 3/8 in 24, so I know I need 3 inches of fall. So I'm going uphill towards that tank to ensure I have gravity this way. So I'm moving my receiver down 3 inches, and now I'm 6'3", moving down to 6 feet in elevation. Let's walk over here to where my tank sits. This elevation represents the deepest that I could set the outlet end of my septic tank and still get gravity fall to a 2-foot deep ditch over there. All right, from this point, we could figure out the tank hole depth and go, but I actually want to do a few checks before we do that, making sure that my stub out works and my tank is not going to be too deep or too shallow. So let's move from here. We'll remember this elevation because we're coming back to it. This one works out really nice because it's 6 feet perfectly in elevation on the ground surface right here. Now, what is the elevation difference between the inlet and outlet? Most of our tank manufacturers, there's a 2-inch difference between inlet and outlet. The inlet's going to be 2 inches higher than the outlet if the tank is sitting level. So I'm going uphill 2 inches. Once again, moving my receiver down. We're now at 5'10", and we're moving to the inlet side of the pot of the tank. All right, we're at the inlet of my tank. Now, to understand if this stub out's gonna work, I need to take another shot real quick. I need to understand the distance between the stub out and my tank. And that distance, to be able to get 1/8 of an inch per foot, it's 8 feet, that's 1 inch. So I need to come down 1 inch. And we're now at 5'9". And now the moment of truth. When I put this in here, if I have to pick up on it to get a beat, we're good. So what we're seeing right now, we're slightly high. It means I just do have enough elevation to get gravity fall down to that drain field. If we set this in this hole at the bottom of the invert of the stub out and I had to pick up to hear a beat, we would not have fall. This stub out wouldn't work. So the stub out will work. We're almost ready to dig our hole. Let's go back and understand how high the tank is gonna be sticking out of the ground or how deep it'll be in the ground before we make our final decision. So I'm gonna work my way back from here back to the outlet end of the tank, because that's where I've got my understanding of how deep the tank hole is. So I'm going back, take this inch out to get back here. Now we're at 5'10", and then I'm gonna take the 2 inches out to get back to outlet end, and now we're back to 6 feet in elevation. And at 6 feet in elevation, I want to show myself what the top of the tank looks like. Most of our concrete tanks, I have 12 inches above this. The top of the concrete on the tank is 12 inches higher than the bottom of the outlet pipe. So I'm gonna move the receiver down a foot now and understand what that looks like with finished grade, compare it to finished grade. So I'm moving a foot higher in elevation. So I'm coming uphill, so receiver goes down. I'm now at from 6 feet to 5 feet. And so now the top of the tank, I would have to bury this a few inches deep. Let's just take a look and see how deep here the top of the tank is gonna be. From 5 feet to 4 feet, 7.5 inches. So the top of my tank in this situation is gonna be exactly 6 inches deep, or right at 6 inches deep, 5.5 inches deep here to the top of my tank. And I'll make a decision. Is that acceptable to me? Is that too deep, too shallow? In this case, they're gonna put a little bit more cover out here, but I think that will be appropriate. And so we now know that our elevations work. If I use that 6 foot to the bottom of the stub out depth, so I'm gonna go back here, put it at 6 feet again, and now I look at the schematics or the designs for the tank I'm gonna use, and I find out that from the bottom of the outlet pipe, this manufacturer says it is 54 inches deeper than the bottom of the tank, so 4 feet, 6 inches deeper than this. And so I'm gonna move my grade rod, my receiver up 4 feet, 6 inches, or 54 inches deeper than this. So we're going to 10.6. I'll set this elevation. And if I dig the tank hole so that it satisfies that depth, I will have it at the appropriate depth to get gravity fall, not have it sticking out of the ground, not have it 3 feet deep, and have fall from the stub out to here. That's the process that we're going to use to understand the full picture of tank hole depth.